Alright, so this picture of a hydrogen atom, supposedly, I think it was taken about 13 years ago, something along those lines. And this is the picture that quite a few people are familiar with, and it's something that I've wanted to address for quite a while. I keep forgetting to. But as has been stated by physicists galore for hundreds, if not thousands of years, there are no such thing as atoms. So we're going to get into exactly how something like this is crafted and how it's used to manipulate people into the loop of circular reasoning that they're caught within. So a good place to start will generally be this article. So why it is and always will be impossible to see an atom, much less an electron. The first reason why it's impossible is because it doesn't exist. No, I'm just kidding. The first reason why it's impossible, and what common sense indicates, is the size. If we cannot even see a microbe, which in comparison to an atom would have the same proportion as a planet compared to a grain of sand, how would we see an atom? But this is not the main reason. After all, there are microscopes. Using lenses, we can see microbes. Just build a microscope large enough, no? No. No matter the microscope size, you will never be able to see an atom. And the reason is contrary to common sense. We see photons. In fact, which those don't exist either, but okay. In fact, we see the stimuli that photons cause in our retina, and the brain interprets as images. Photons are subatomic particles that are absorbed and emitted by atoms, so the real reason we can't see atoms, and we never will be able to see, is because this is impossible for our eye apparatus. Okay. So the main idea here being that it's simply, in concept, too small to see with any sort of light-based optic, and they try to invoke the existence of photons, but again, this is another virtual particle. What they're really trying to say is that you couldn't see something like an atom with light because of the way that light supposedly interacts with atoms. Whatever, it's a good enough explanation for a start. So, and then he goes on to show this, which is the hydrogen atom. It continues, wow, how is this possible? Didn't you just say that human eyes can't see an atom? Yes, and this remains true. This photo of the hydrogen atom was made using the human being's ingenuity to translate something invisible to us into a visible representation. Oh, here we go. The researchers who achieved this feat used a photoionization microscope. It is a device that bombarded hydrogen atoms trapped in an electric field with laser pulses. Okay, because laser pulses are what, in modern science, they always claim that they can pulse electrons using lasers. No such thing as electrons. All they're doing is pulsing laser beams. That's literally it. It's just very short pulses of laser beams. This excites the electrons in the hydrogen nuclei's orbit, and some of them ended up being thrown into a detector. After doing this several times, stimulating electrons in many different ways, they finally formed this image, which is the closest representation of a hydrogen atom's electron cloud. That is, this isn't a real image of an atom, we will simply never see one, but it's the closest representation. Okay? Now, he kind of explains it right there, but what he's nudging around with his phrasing is that this picture was literally created by a computer. Okay? It is a composite image. Right? Yes, the widely publicized photo of the hydrogen atom's electron cloud is indeed a composite image, not a single snapshot, created by researchers using a quantum microscope, whatever. This technique combines information from the hydrogen atom's quantum wave function, showing the probability distribution of its single electron. Okay, blah, blah, blah. What does that mean, right? What does that mean? Because they love to dance around this shit. The famous picture of the hydrogen atom's electron cloud is not a direct photograph, but a composite reconstruction. A triumph, so-called, of experimental design and quantum inference. Quantum inference. Here's how it was created. The experiment FOM Institute, Amolf, Amsterdam, 2013, so 12 years ago, led by Annetta Stodolna and colleagues. The team used a technique akin to quantum tomography. They excited hydrogen atoms using a laser, bumping the electron into a high-energy Rydberg state. This caused the electron to escape the atom and travel toward a detector placed half a meter away. The detector recorded the impact positions. Alright, fuck all this. This is what we're getting at here. The detector recorded the impact positions of these electrons, so-called, each one a single data point. All the detector recorded was wave patterns. It just picked up on signals. That's it. So it records the impact position of these so-called electrons, each one a single data point. Repetition and reconstruction. The experiment was repeated hundreds of thousands of times. Hundreds of thousands of times. Each with a fresh hydrogen atom, so-called. Okay, it's just a cloud of hydrogen. The resulting data formed a statistical map of where electrons were most likely to be found before ionization. A computer, here we go, here it is, a computer then reconstructed the orbital, the region of space where the electron's presence is most probable. The image uses color gradients to represent detection frequency, right? So everything about the image is completely computer generated. It's a composite image of hundreds of thousands of photos, or at least that's the implication here. Right? The experiment was repeated hundreds of thousands of times. They color it, they reconstruct it based off of data points, right? So they literally use the computer to generate this image. Okay, like, do you see how this shit works? And this is one of, like I said, this is one of the particular things that I wanted to own here. Not a snapshot, but a quantum statistical portrait, as in it's bullshit. So I really wanted to hone in on this for a while, because often when you have this conversation with people that aren't aware of these things, and you say something like atoms don't exist, this is one of the first things they'll think of. Like, well, atoms have to exist. Let me see. It was Niels Bohr. Atoms are abstractions. Hopefully this comes up relatively quick. Isolated material particles. There it is. Here, since that's taken a while. Niels Bohr, and this is the father of the Bohr atom of the model that they always show kids in school. Isolated material particles are abstractions, their properties being definable and observable only through their interaction with other systems. Right? That's from the father of the modern atomic model, so to speak. Pancake. And what is he saying here? He's saying that all you can do is measure interactions of fields. That's it. That's it. There are no such things as atoms. Now, one of the things that people have a hard time with is trying to break things down into smaller components. Because, like, okay, well, how can, and I've had somebody say this to me before, like, how can things possibly break down into smaller components if there's no such things as atoms? This is it's a false equivalency, to say the least. Obviously, you know that things can break down into smaller things, but utilizing that same logic, if you think that because things can be broken down into smaller things, there must be atoms, as in like Lego building blocks that for some reason make everything. Using that same logic, you would be forced to also admit that at some point, when you get down to subatomic particles and quarks and so on and so forth, you're going to reach a point where the first thing composing that thing has to come into existence. Right? Like, the very first thing has to come into existence. So What I'm saying here is that it can't actually be made of anything. And hopefully that makes sense. It can't actually be made of anything because there was nothing there to begin with. Right? This is like, it's like trying to argue that a dream has to be made of atoms because you can see the things in the dream. And the things in the dream can break down into smaller things, so it must be made of atoms. No, it doesn't have to be made of anything. And that's the paradox of life. All right, much love.